Good evening, class. Tonight we're going to continue finding equivalent fractions, similar to what we've been doing the last few days. So it shouldn't be anything too challenging tonight. So up on the screen here, I have a whole bunch of numbers, and I want you to find common denominators for each set. So for 3, 4, 6, what would be a common denominator that we could use? Well, they all can go into 12, right? So 12 would be a good number to use. What about 4, 5, and 20? They can all go into 20. 7 and 8, well, I know 7 times 8 is 56, so I can use 56. And that's what you can do for all of these here. 8, 2, and 4, they can all go into 8. 6 and 7 can go into 42. 5, 10, and 15. We don't want to use 15 because we know 10 can't go into 15. I know that they can all go into 30. Well, 3, 9, and 36, they can all go into 36. 5 and 15 can go into 15. 11 and 8, probably 88. All right, so today we'll be working with the division rule and the multiplication rule. And these are rules that you're actually already familiar with. Remember the phrase that we've been repeating for the last few days? Whatever you do on the bottom, you must do on the top. That's basically all we have to know in order to apply these two rules here. If I divide the bottom by something, I will divide the top by that same thing. If I multiply the bottom by something, I multiply the top by the same thing. Easy. So here we have 3 7s. How can we find an equivalent fraction to that? Well, let's start by using a fraction stick here. This stick here is cut into 7 pieces. So I'm going to shade in 3 pieces. So I can see that's 3 7s there. Now what if I take this stick here and I cut it in half? Like that. How many pieces do I have now? Well, I have 14, right? And how many pieces do I have shaded in? I have 6. So I know 6 over 14 is equal to 3 7s. And I can cut this stick up into more pieces too and find other equivalent fractions to 3 7s. So let's do this next example here without using a fraction stick. We have 3/5 equals something over 35. Well, let's use the multiplication rule here. If we take 5 times 7, that will give us 35. Now, since we did that on the bottom, we have to do that on the top. So I'm going to take 3 times 7 to give me 21. So I know that 21 over 35 is equivalent to 3/5. What about here? I have 4 over 1 equals to 12 over something. Well, it's the same thing that we just did, except that it's denominators now that we don't know. So in the numerator, I took 4 times 3 to give me 12. So I'm going to do the same thing in the denominator. 1 times 3 is 3. So 12 over 3 is equivalent to 4 over 1. Oh, here, I have 25 over something equals 5 over 2. Let's work with the division rule this time. 25 divided by what will give me 5? Well, I know 25 divided by 5 is 5. So what number divided by 5 gives me 2? 10, right? 10 divided by 5 is 2. So we know 25 over 10 is equivalent to 5 over 2. Now you could also do this problem by using the multiplication rule, right? I could have taken 5 times 5 to give me 25, which means 2 times 5 gives me 10. The same answer. So whichever way works easier for you, as long as you can understand both ways to use multiplication and division, then you're golden. So here I have 3/5 equals something over 100. So let's go ahead and try the multiplication rule here. 5 times 20 is 100, right? So let's take 3 times 20. This gives me 60. So 60 over 100 is equivalent to 3/5. Lastly here, let's determine if these fractions are equivalent or not. Now we can use either multiplication or division. So let's go ahead and reduce 4/10 down and see if we can get 2/5. So I'm going to do division here. I know 10 divided by 2 is equal to 5. So I'm going to take 4 divided by 2, and that's going to give me 2. And that is equivalent to 2/5, right? So we know that these two here are equal. If we wanted to use the multiplication rule, we could have done that too. We could have come over to this side here and put 10 down here, and we would have realized that 5 times 2 is 10. So I would have done the same thing to the numerator. 2 times 2, 4. 4/10 is equal to 4/10, so those are equal. Let's look at another example here. I have 1/3 and 4/8. Is it possible for these two to be equal? Well, let's look at the denominators. Is it possible for 3 to go into 8? No. But let's go ahead and try and reduce 4/8 down anyways. If I try to reduce this down, I could put a 2 here. I know 8 divided by 4 is 2. So 4 divided by 4 is 1. I get 1/2, but that is not equivalent to 1/3. Okay? So hopefully this helped your understanding of fractions. There was nothing too entirely new in this video. Just remember that we can use both division and multiplication rules to find equivalent fractions. All right? Looking forward to working on this more with you tomorrow. See you then.